What's up, yo? My name is Pepe, or at Albert J. Black in social media. If you want, you can follow me here. I'm a computer science student, and today I'm going to tell you all you need to know about computers. I do not fear computers. I fear lack of them. That's why you should learn everything you can about them. Enjoy. Back in the day, computers were not made of ones and zeros. In fact, they were big mechanical machines that took the size of an entire room. Amazingly wicked, right? In fact, computers back in the day worked in base 10, meaning they did not use binary. They used some mechanical kind of rounded cylinders that used some kind of gears to connect and calculate and compute things together. But as calculations became more complex, they decided to get rid of all the gears that they have for mechanical computers. No more base 10 anymore, so engineers and scientists got together and they developed a system, the system that computers use today. Binary, which you guys already know, it's ones and zeros. A little sidebar here, we're gonna talk about binary numbers a little bit. If you want, you can skip ahead to the minute that will be appearing here so that you can continue keeping on with this video. So each number, either 1 or 0, would represent itself multiplied by 2 raised to the power of n, which n means the position that it takes in the array of numbers. I know, a little bit tricky, but stay with me. To identify a binary number, we use the term binary word, which is just a series of characters of ones and zeros that represent a number. In this case, we have 0, 1, 0, 1, 0. You read the number from right to left. The numbers that you see here in pink color represent the position, the index of each element. This index would be the value n in each case. One important thing to notice is that the indexing starts at position 0. We don't use number 1 to start counting as we would use in a regular system. You don't say 1, 2, 3, and so on. You say 0, 1, 2, 3, and so on. Each element in the binary word is associated with a specific index. So to calculate the value of, for example, let's say, this number, we would take itself, in this case number 0, multiply it by 2 raised to the n, the index, which will be 0 in this case. As you can see, the correct calculation for this number, 0 at position 0, would be 0 times 2, because it's what we have as a base, that's why it's called binary, raised to the position, which in this case the index is 0. 2 to the 0 is 1, times 0, 0. So to get the total value of this word, we have to do the same process for each member. So the number, or binary word as you may call it, 0, 1, 0, 1, 0, in a regular system would be the number 10. If you want to know more about them, subscribe to this channel and leave a comment down below, and also a like for the YouTube algorithm. This sentence is right. A computer was an accountant, a person that used to do a lot of calculations by hand. Today, when we say computer, we mean I/O devices, input and output devices that help us process data, interact with data, and output our results. Back to their core, computers just perform calculations. So have they really evolved? I don't know, it's up to you to decide. So as you guys know, engineers and scientists got together again, and they came up with a better computer. An electrical and mechanical combination of both systems that is the computer that we have today. The assembly language was hard to understand, but I want to give you a basic idea of how the syntax was and still is if you want to use it. Quick question, do you know what this does in assembly? This line of code is basically saying, divide what's stored in location 96 by 5 and store the value in location 99 of the memory. Going back to a general outlook of a computer, they still share some components. Mainly switches allow the current to flow through the circuit. The electric flow circulates, and if we have a voltage that's negative, we represent it with a 0. And the current stops flowing or doesn't flow. Else, we represent it with a 1. It's supposed to flow. Processors are just circuits. They execute a list of calculations or instructions, which are instructed to the computer via switches. You configure the switches, then they get stored in the memory, well, at least the instructions or the calculations get stored in the memory. And then the processor, the circuit, deals with that. Here's a little curious data you might have not known before. A series of instructions is also called a program or an application. It's up to you how you call it. We were just talking about circuits with processors, right? But memory is another type of circuit that stores ones and zeros in address locations. For example, that's your computer's memory. The location 0, 1, 2, 3, 4, and so on. These are address memory locations, not only because they have an index, but because this index can help you reference back to that memory location at a later point. Interactions are just a combination of the work that processors and memory do together. We already went through an interaction. Can you say what that was? I'll give you 30 seconds to do it. And also to like this video and subscribe. Why not? Okay, I think the time has passed. The previous interaction that we went through before is div, a number location, a number, and another location, which says divide the value that's inside location 95 by 5 and store the result in location 99. That's basically an instruction, but that is coded in assembly, which I've already told you is a dev language and so hard to deal with. That's why Java and C and so many other languages like Python arise. But we're not talking about language history in this video. Hold on, we're almost done with the video, so don't go away just yet. This is the last part of the video, where we will guide you through a computer tour that will tell you all about other components that might and might not be involved in every computer. Usually they are. Peripherals are auxiliary devices that help us interact with the computer via input and output operations. Your most basic input type of devices of peripherals would be a keyboard, where you would type your password or your digital fingerprint every time you log into your computer. If we're talking about output, we have your screen monitor, where you see an image of everything from your web browser, to your photos, to your apps, of everything. Storage usually refers to disks, the things that keep all your information from your computer. They differ from memory, and I will tell you why in a second. Most of disks are non-volatile, which means that they maintain information even when your computer is off. You wouldn't want to lose all the information you have when you turn it off, would you? Memory deals with short-term data, or volatile. It means that, yeah, it's bipolar, and it loses all your data once it is turned off. So we have the RAM, which is an example of memory. It's random access memory, which helps you deal with memory that you use a lot of times in your computer, so the process is more efficient, and you don't have to go all the way to the disk and retrieve the information. CPUs are basically processors. They deal with the initial programs that you have to run for your computer to work, mainly the BIOS, which is the basic, input, and output. That is the main program that your computer has to run for everything to work. Then, they also deal with something sort of like a RAM memory, which is called a cache. Better the speed for you to access the most recent files in memory. But they're not in memory, they're in these volatile disks. Initially, CPUs when your computer is turned on. Then you go to memory 0 and see what program is there, usually BIOS. Then you run in, and then your computer starts to work. Clocks and switches are the last part of this video. Clocks just deal with the speed that the processor has. For example, 1 megahertz, which means that your processor ticks, like process data and ticks and speeds and all that, 1 million times per second. Or you want to be a bit more speedy and go with 1 gigahertz, 1 billion ticks per second. They basically set the speed of your processor. Transistors basically conduct current in integrated circuits, so they can activate switches, and you can activate instructions for the computer. We've seen computers evolve through time, from being mechanical computers, machines, electrical components bunched together, accountants, but we know that at their core, all they do is perform basic calculations. So all you have to do is keep watching my channel to know more about them. Have a good one.